Okay, welcome everyone once again to the class today. As time goes on, I believe every other person will join the class. And yeah, we were able to begin the official Stellar Boot Camp yesterday, and I'm very happy we all were able to attend yesterday. But before we proceed today, I'll start by asking a question. Is there any question anyone from previous class have based on the previous class we had yesterday? So we can tackle that question before we move on with today's class. So if you have any question, you can just use the raise hand button. Okay, Keisha, can we hear?
Okay, sir, I didn't get about the
Okay,
consensus
okay,
yesterday.
great. Consensus. So you did not get the full idea of what the consensus mechanism was all about. Good. So apart from Keisha, is there any other person that did not get so much as understand something from yesterday's class? Okay. Since there are no other persons, I would start by sharing this slide and I would then go straight up to your question on the consensus mechanism. So yeah. So Keisha, I'll start by asking you, would you explain what a blockchain is to me based on the class we had yesterday? What is a blockchain, Keisha?
A blockchain
Yes.
is a ledger that is decentralized
Okay.
and it records transactions across many computers in such a way that it can't be altered.
Excellent answer. I'm very proud that you made mention of the most important point I want to actually see from what a blockchain literally is. You made mention of decentralization, immutability, and the fact that it is transparent. So that is exactly the answer to my question. Now, going to consensus mechanism. I use the example of three of us staying in a room to explain what a blockchain is. Now, from that example I made mention of yesterday, I said, I do not trust the other person. That is, I do not trust Alice, I do not trust Bob, and I do not trust Tola. Others don't trust me too. So how are we sure that every single thing, every single person would be entering into that particular ledger is true? And this is where consensus mechanism comes in. Now, I explained from yesterday's class that consensus mechanism, different blockchains have different consensus mechanism they use to ensure that all the different nodes that participate in the chain have the same exact transactions on them. And I started by talking about Bitcoin. I made mention that Bitcoin uses the proof of work consensus mechanism. Then Ethereum uses proof of stake consensus mechanism. They literally moved to proof of stake after Ethereum 2.0 to proof of stake. Then for Stellar, Stellar used federated Byzantine for their own proof of for their own consensus mechanism. So it's literally the mechanism that's part of the blockchain client that allows all the nodes on the chain to to come to an agreement of the transactions that are imputed in all of this ledger. And that was what I explained as what the consensus mechanism is. So did you get that, Keisha?
Understood.
Makes sense. So I would do a brief overview of what we discussed yesterday, and we will proceed from there. Although today I said I'm going to start by using a graphical illustration to explain what a blockchain truly is. I made mention that I would use a graphical illustration to see how hash is being done, which I actually showed. But then how does it correlate or how does it connect to the blockchain? What is being hashed in the blockchain? Now, I made mention of ledgers linked together to form a block and blocks linked together to form the blockchain. How exactly does this work? How can we visualize this? All of this is what we are going to see in the class, although I want you to have it at the back of your mind that it is a simulation of how the blockchain works. So you're getting a vivid example of what it looks like for the blockchain. But before that, I would like to do a simple overview on everything we've discussed yesterday, just to bring our mind back to everything we've spoken about. Now, we started the class with Kisha asking the question, what consensus mechanism is, and I asked her what the blockchain is, which she rightly answered, and I'm very happy for her answer. And what did her answer comprise? Decentralization, transparency, immutability. Literally what the blockchain is, that is having no center point of control. Different people from different geographical location running a client on their local machine, which you would call a node, and literally accepting, sending transaction, verifying transaction on the blockchain. The blockchain is transparent. It cannot be muted after transactions have been added to the blocks. So this is literally the feature of the blockchain, just like I explained from yesterday. Another thing we spoke about is the history and the evolution of the blockchain. We started by talking about the concepts that was created by Stewart and Scott. Both of them didn't want documents to be tampered. And one important thing they did to avoid this is they were trying to create timestamp on each document. So each document with the timestamp, the digital timestamp with it, would ascertain that this document is not tampered because it was created at so time and it cannot be backdated. So that was literally the first concept of blockchain. And then we moved on to talking about BTC, which is known as Bitcoin. And we mentioned that some group of people or a person under the pseudo Satoshi Nakamoto literally created Bitcoin, and it was known as the first application of the Bitcoin technology. And from yesterday's class, I explained the simple idea behind Bitcoin. It's called UTXO. So Bitcoin makes use of what we call unspent transaction. In literal terms, it's just addition and subtraction, but it comes with all of these concepts I have discussed about the node, the gossiping layer, and all of that. But on the outside layer, for a overview of everything, it has nothing to do with an execution layer. And this is what I explained, brought about what happened in 2015 when Vitalik Buterin and Gavin Wood came together and they were like, let's do this. And they were able to come about Ethereum in 2015. And Ethereum introduced something Bitcoin doesn't have, that is an execution layer. And what does the execution layer do? It literally allows for the deployment of smart contracts. And with deployment of smart contracts, I mentioned from yesterday's class that you can literally write any application and deploy on the Ethereum chain. And that was what I spoke about and explained about the Ethereum. And we then spoke about major milestones when it came to Ethereum, when it came to Bitcoin, and the other ecosystem when it comes to blockchain. We spoke about the first Bitcoin transaction, that's the pizza purchase, which is even still celebrated until today. Then we spoke about the emergence of alternative cryptocurrencies, which you would personally know for those that have been smart contract developers, we know use the concept of what we call ERC20 tokens. Then on to 2017, where we started seeing ICOs and widespread of the blockchain. And then finally 2020, we spoke about decentralized finance, when we start talking about the automated market maker, that's AMM that I made mention, was created by Uniswap, and then other people started adopting it and started creating their own market makers. Then we also spoke about non-fungible tokens, that's NFTs gaining popularity everywhere, and all of these 2020 and up till now 2025, when even bigger infrastructures are then built on the blockchain. So we also spoke about how the blockchain literally works. I spoke about how the transactions are collated in a ledger, and then the ledger is then added up to make up a block, and then the block is then hashed, and it is then joined to previous block to form the blockchain. So the block structure has the header and the transaction. So the header contains metadata such as the previous block hash, the timestamp, and a nonce. So all of these things, we are going to see the practical example from today's class. As I have made mention of, graphically, we would see it. And yeah, and I think there's something I haven't said. For every single class, every week, I want to ensure that we are having a form of test. Because at the end of this semester, for this cohort, certificates will actually be given out. It will be given out, and for those that are below a certain amount of, class score, you would not be opportune to get your certificate. And trust me, you really want to get this certificate. So that's that for that. So other things is the data storage and the linking, each block referencing the hash of the previous block and forming a chain. And this ensures that altering a single block will require altering all subsequent blocks, making tampering difficult. Okay. Emily has a question. You can unmute and speak, Emily. You can unmute and speak, Emily. Emily, you can unmute and speak your answer up. Or is that a mistake? Can everyone still hear me? Can I get a thumbs up if everyone can still hear me? Okay, great. Great. So Emily, your hands are up. You bring them down if it's a mistake. Okay, thank you. So I'll just continue. So what I just explained about data storage and linking, I want you to have it at the back of your mind, because what I'll be demonstrating today would literally show it. Read and listen to this sentence. This ensures that altering a single block would require altering all subsequent blocks, making tampering difficult. And this is literally, as I explained yesterday, why the blockchain is immutable, because there are a bunch of data that are linked up together through cryptographic hashes. And so if you tamper one, you have to change the remaining ones that you have tampered for it to correlate again. We made mention of different blockchain terminologies. We spoke about smart contract, node, a ledger, a consensus, hash, and wallet. I said smart contract are self-executing contracts with terms differently written into the code. And then I broke that down from yesterday's class that it is literally a bunch of codes that execute certain actions that are irreversible. So if you write, the example I used from yesterday's class was, if you have two functions in your smart contracts and you deploy them, a function sets your name, the other function reads your name from the chain. I can hear a voice. Okay. Okay. So one function sets your name, the other function reads your name from the chain. You can only do that for that smart contract you have deployed. It executes only what you write there. That is what a smart contract is. I made mention of other things like upgradable standards, which we will talk about, but I'm not going to talk about it now. But then what then are upgradable standards? How do they affect what I'm saying about your smart contract doing exactly what you want it to do? And then someone is talking about upgradable standard. I said it yesterday that we will not be talking about that now. Nodes. Simple definition of node is that your laptop can serve as your node, your computer can serve as a node. All it has to do is download the clients for the blockchain you want to participate in and run it. But I made mention that your laptop has to pass certain specification because different chains already have different sizes and the required memory when it comes to RAM and ROM needed to run the chain. I just want to be sure the class is being recorded. Okay, it's being recorded. Okay. Then ledger, I made mention that a ledger is literally a record of all transactions, and a ledger is what accumulates up to form up a block. So for new transactions, all of them are entered into a ledger. We are going to see an example of that also in today's class. The consensus mechanism, we've explained this too much. Someone else's hand up again. Sunday, are you saying something?
Oh, sorry about that. Sorry.
Okay. Then hashes. I explained what hash is. It's a cryptographic function that converts input data into a fixed length string. I explained that from yesterday's class. All of this, remember, is just an overview of yesterday's class. And you might wonder why I'm actually doing more like an overview that's taking so much time. It's because I believe in what we call reinforced learning. When you learn and you reteach what you have learned, it sticks more and you are able to remember it for a very long time. So what is decentralization? That is what we'll be starting with for today's class. But before that, I would then share my screen to illustrate what I made mention of that I would use to show what a blockchain literally looks like. So give me a second and you can see it. Okay, can everyone see my screen clearly? A thumbs up if everyone can see my screen clearly. Okay, great. Okay. Let me be sure I'm sharing the right screen. Okay, good. So what you can see from my screen is one of what I explained to you yesterday, but it is just the beginning. Now I explained what an hash is. It's literally a function that converts a length of string of data, any length of string of data. I mean, in fact, you could call it any data, because now when we are talking about data, a data could be file, it could be a video, it could be an audio file, any data to a fixed length of string. That is literally what a hash function is. But in our case, our data is just going to be a string. And in this string, I'm going to say the string is literally my name is Ayomide. Now, we saw all of this from yesterday's class. We made mention that for a cryptographic hash, a single change would cause a large effect in the output of the hash. So we can type something so long also, we get the same fixed string length. Good. That is literally what an hash is. Now, what then is a block? What does a block look like? We move on to this. Move on to this, and it gives us illustration of what a block is. So a block has the number, it has the nouns, now it has a data. So now let's imagine this data includes all the transactions. So let's say, let's use the example of what I was saying some times ago. about me, Tola, Bob, and Alice. So let's say Alice has, let's say, $2. Or let's start everybody by having everybody have $100. Ayo has $100 too. Okay, let's not leave space. Then let's say Bob has $100 too. Then we made mention of Tola have $100 too. So now, if I mine this literally becomes the new hash of this particular transaction data. Now we are trying to explain what creates a block, then how the block is then linked to become a blockchain, before we can then talk about why in fact it is distributed. And so this is a vivid example of it. Now, every single data that is there, the block, the nonce, and the data, everything has been hashed to give this output. So in this case, we can call this hash the hash of this particular block. That's the block hash for this. So notice that I had to mine this before I could get the current hash for this. If I cancel this and nothing is here, notice it turns to red because the hash of this empty data is different from the hash of the data we had initially. So I have to mine this again before I can get a completely different block hash for this. And that's just how it is. So the next thing we are going to do, and is there someone raising his hand? Does everyone understand? Can I see a thumbs up if everyone understands what I've just explained? Okay, Lufefe, you have your hands raised up.
Yes, hi, everyone. Thank you so much for the question.
Could you speak
I'm
up
just
louder a little bit?
okay, so sorry. I'm just getting confused. No, not really confused, but I think I just misunderstanding. Do you take mine? When do you take mine? Is it after you enter the transactions, and then it's gonna generate a new clean sheet, or you yeah, that's what or you have to remove like clear the space.
Okay,
I don't, I'm not sure if it-
you, you were not exactly clear, but I'll just repeat what I heard to be sure. Are you saying what exactly does this mine does, right? Is that what you are getting at?
yes,
In
yes.
simple terms, just see it as what hashes the whole transaction that has happened in this block to give a transaction hash. And you don't have to worry about this for now, because as we proceed, you will then understand why we need this transaction hash in the first place. Notice that we started by talking about the hash, and I extensively even showed the different place and different types of cryptographic hashes. But today, I'm just using this SHA-256 hash for this example. And I showed what the hashing looks like, what happens when you hash a data. And so now we have a block of that includes the block number, the nonce, and the data, and everything has been hashed into this. So then the next question would then be, what exactly does this hash have to do with what we are doing? Why are we even hashing this data? That leads to the example of what a blockchain looks like. Now, what can we see from here? We see block 1, we see block 2, we see block 3. All of these, we see block 4, we see block 5. All of this is a simulated example of what a blockchain now looks like. Now for block 1 has 1, it has the nonce 11316. Then the data is empty here. Then it has something called previous hash. what is the previous hash as we can see here? We can see 0, right? This is because the previous hash of the Genesis block is 0. And what the Genesis block means is that the very first block. So the very first block that started the whole block of chains is the Genesis block. So the previous hash is what? Is 0. So, but what then is the hash of this current block is this. Now, we moved on. Imagine the ledger has filled up this particular block. And so we are moving on to block 2, as you can see here. So for block 2, the previous hash for block 2 is the hash of block 1, as you can see. That is what links them together. Now, block 2 also has its own hash. Its own hash is the hash of all the data plus the hash of the previous block. That is what then links block 1 to block 2. The same happens to block 3. Now, notice that block 3 has the previous hash of block 2. Okay, sorry. Here is the previous hash of block 2 that ends with C119. And here it is. And then it also has its hash of its own. So that means everything that is being hashed here includes the hash of the previous block. So the previous block hash is what links the current block to the previous block. The same thing happens to the next block, that's block 4 and block 5. Now, imagine we now have what we had here before. We had Ayo, $10, and so. Notice that everything turns red. Why did everything turn red? That is because the hash of this block is now completely different from what this one is seeing as the previous hash. So that means all the data that is altered here has affected the hash of this particular block. So that means if you alter anything here, it will reflect on this particular block because the hash is what links them together. Does that make sense? Now, imagine we now hash this, we mine this, and then we have a new hash. Now, the new hash ends with F47, 18F47. This is the new hash. Now, this is it. But this one, we have to remind this one for it to have the same connection. So it has a new hash again, and this new hash is linked to this, Then we have to rehash this one again. So once we mine this, notice that something is changing as we are mining every single one of it. Can someone tell me something that is changing? Raise your hand if you can notice something that changed for every single block we hashed. Jonas Zim, can you tell us what changed? You can unmute.
Well, what is changing is the colors from red to green as we are mining new hash.
That's very correct.
Can you hear me?
Yes, I heard you. You said the color changes as we are hashing it. That's one correct answer.
Yes.
That's correct. So when you hash it, the color change, yes, to show that, okay, now this block is now really connected to this previous block. But then, can someone else tell me another thing that changed as you mine? Okay. Can we have Eliwaha Shailaga? I'm sorry if I did not pronounce that well, please.
Yeah, my name is Eliyahu Chaliga.
Okay.
So what has changed is the previous hash become the previous hash updated for the next block.
Excellent answer. That is another thing that changed. The previous hash compared to the new block hash. Correct? Something else also changed again. Did anybody notice something else that changed? Okay.
The nonce changes.
Excellent answer. That's in fact the first answer I wanted to get. Thank you very much. The nonce changes. So notice that we have not hashed this particular block. So if I hash it, notice that the nonce is 35990. If I hash it, that's if I mine this new block, the nonce has changed. Remember when I was saying that mining is literally solving some kind of cryptographic problems to get a particular nonce? That is what happened here. This block was mined to get a new nonce that corresponds with the previous hash. So thank you very much, everyone that answered my question. So can you see why we say it is very difficult to mutate the blockchain? That is because once you change a data, if there's any malicious person changing a data from his own, every single block has to be mined all over again. But now, a question might now pop up that, okay, since I'm the owner of this block, as you can see, my own block, I can literally remine it. If I change this data, or let's say I change this one, I can mine this one again, come here, mine this one again, mine this one, and then I keep mining, and then everything is fine again. What then can we say about this situation? Can we really say it is then secured? This is what leads us to what we call the distributed system. Now, in the distributed system, it is no longer one person. Can we see? It is no longer one person. We now have peer A, we have peer A, we have peer B, we have peer C. So this particular person is serving as his own node. Oh, sorry. This particular person is serving as his own node. He has his own blocks that makes up the blockchain. That's the chain is running. Then this peer B also has his own blocks that makes up the blockchain that is mining on his own local computer. This last person too has his own that makes up his own block that is mining on its own node, his own computer, literally. So the question is now, how does this affect the whole system? So let's say this person, let's use peer B. Let's say this person wants to change a transaction on the chain. So he comes here and say, oh no, this thing is not, Ayo does not have $100. Let's use Ayo. Ayo is my name, so don't get tired of listening to Ayo. So let's say Ayo does not have $100. Instead, he has $1,000. So notice his own particular block is now red as the color has changed. Now we now acted malicious. It's now like, okay, I'll quickly mine it. I'll quickly mine everything. Now it is green back, right? What then is the problem with this situation? Notice that the end of the hash for everybody is this. It ends at D217C. But what is its own last block hash? That's block 5 hash. It ends with OEE3. So the block hash is completely different from the block hash of every other person. Look at the block hash of this last person, D217C. Completely the same thing with peer A and peer C are completely the same. So that means that when the network notices this malicious person, the network automatically does what? It kicks the person out of the network. Now, different blockchains have different ways they deal with malicious individuals. For example, for the proof of stake, which is Ethereum, that you have to stake certain amount of Ethereum to participate in the proof of stake, your stake is being slashed into two. So that is one of the security mechanisms for it, to ensure that all participants of the blockchains literally are honest. So there's penalty for being dishonest. Now, let's now move on to a situation whereby, oh, the chain has now upgraded and we now have tokens that are deployed on the chain. Notice that every single transaction, now look at this transaction. We have the transaction includes $25 from Darcy to Bengley, and then about $4.27 from Elizabeth to Jane. All of these are transactions. All of these transactions, one by one. Remember that notebook, that ledger? Imagine this is everything. So now everything now comes together to make a block, and then the block is being hashed to connect with the next block, and then from the next block, we have it connecting on and on and on and on like that. So at a very particular point, if someone changes just one thing, let's say I change that, okay, this transaction didn't come from Bishop, instead it came from Ayo. It came from Ayo. Notice that everything is now different. So if I mine this block, and I mine it here, and I come here and I mine it and say, okay, let's mine it so that the transaction hash will be the same. If this one is still mining, then I mine this, everything now corresponds together. Notice that at the end of the day, the final block hash, that is the current block hash, the latest block hash would be different from others' own. Notice this one ending with F253. This one is ending with BE3A, and this one is ending with something BE3A. So these two are the same, and this one is not the same. At this particular point, we can say this person has been dishonest and he should be kicked out of the system, or he should face the penalty. So that is literally the idea of what the blockchain looks like. So does anybody have any question from this illustration I've used to explain a simple demonstration of how the blockchain works? Can I get a thumbs up if we are all satisfied to move on? Okay, great. Okay, great. So I'll stop sharing screen and I'll go back to my slide, and then we would continue talking about what we are meant to start with or talk about with today. And that is what we call decentralization. What is decentralization? Looking at the example I've given earlier, it should literally give explanation of what decentralization is. Decentralization just means that control is distributed across multiple participants rather than it being centralized in one place. Imagine you are using, for those in Nigeria, imagine you are using First Bank as your bank. First Bank is the one that will show you your bank balance. I think I used this example before. They are the only ones that have your bank balance to show you. Nobody will show you apart from them. So if you want to do anything, if they remove 1,000 Naira, 1,000 CDs, 1,000 pounds from your account, all of these things, you can only go to First Bank for them to print the transaction receipt to show you. You can't check it from any place. That is an example of a centralized entity. So unlike that centralized entity, the demo I just showed you showed a distributed network that includes all the different transactions that every single person participated in. So let's say I sent you 1,000 Naira. The 1,000 Naira will show that, yes, I sent it to you. And it will show on Tola's page, on Tola's node, it will show on Alice's node, it will show on Bob's node. And it will show on every single person's node. So this is a decentralized system. And an example of decentralized system is what we have been talking about since Bitcoin, Ethereum, Stellar, and other chains. Centralized systems, they are traditional banks, centralized exchanges, which we will be talking about too. Are they not operating on the blockchain? How is it centralized? I believe that question will come up later on, but we'll talk about it as time goes on. What is then the importance of the blockchain? Increasing security by reducing single points of failure. That is, for example, if my own node that I am using to record the transaction is down, because anybody that is running the blockchain client, any blockchain client on a system, he has to be online 24/7. So some people pay for VPS and others literally have their system on with internet 24/7. Others use client servers and all of that to run it. So your system has to be on. Imagine someone is using his own personal computer at home and is living in a place where they have NEPA issue, that is electricity issue. For those kind of persons, it might be difficult for them to stay online all the time. Imagine they were using their own computers for this. So in that particular case, would you say because someone's node is down, the whole node will be down? No. The other people that are online and then transaction continues and then it can be verified continuously from other sources apart from you. And whenever you join it back, then it is good to go. Please give me a second. Okay, sorry for that. So whenever you join it back, it continues. And so there is no single point of failure, literally. Another thing is it enhances transparency and trust among participants. Everybody can see everything going on in the blockchain. For example, if you go to your bank and say, give me my transaction receipts that has happened from last 2 years, it is what they give you, you have to believe, literally. But then on the blockchain, you don't have to ask anybody, you just go to BlockScan, or if you have your own node you are running on your private computer, you can literally go through the block transactions. And with this, you can see every single thing that is there. And so there is transparency. No one is hiding anything from anybody. Everything is clear, distributed, and transparent. So there's trust. And anybody that is trying to perform as if he's smarter than himself is kicked out of the system because the system automatically detects outliers. Another thing is it promotes resilience and resistance to censorships. So, sorry, let me take this too. I'm sorry. Okay, back to class. So it promotes resilience and resistance to censorship. So what does this mean? This means that for centralized entities, a bank can say, okay, I want to ban this person. You can't use our bank anymore. You've done this, this, and this. Whether it's something good or bad, they can choose for you not to use the system anymore. Other centralized entities like some social media network, you hear about a particular social media network right now that a particular group are being banned from using it, and so they don't have access to say, okay, they want to use it because it is being centralized against them. But then the blockchain is not like that. Everybody have access to the blockchain and can literally do anything on the blockchain. So there's no censorship. The consensus mechanism. Okay, Miriam, you have a question. Can we hear your question, Miriam? Your hand was raised.
Okay, thank you, Aya. So my question was, by saying transparency, so can I see other people's transactions, just people on the block? So will I be able to see other people's transaction, or what do you mean by saying transparency?
That's exactly it. You would be able to see every single person's transaction on the blockchain. So let's say I sent you $1,000. As long as I have the transaction hash, every single person can see it. You just have to go to a transaction, the blockchain scan. Now, different blockchains have different scan. You get for Stellar has its own scan, Ethereum has its own scan. Different people can literally, you yourself, you can build a scan yourself that allows people to see transaction. It's all about having access to the client itself and participating in the network, and then you can literally release out the data for people to see. So whatever happens on the blockchain, every single person can see it. So it is transparent like that. So yes. Consensus mechanism. A consensus mechanism, we've spoken about this so many times, but don't get tired of hearing it. Is the process used by the blockchain network to achieve agreement on the state of ledger. We know what it means, but then what then is the importance of the consensus mechanism? The importance is to ensure that everybody is saying the truth. Nobody is a liar. And if you can't trust anybody, you are living in Japan, I'm living in Nigeria. Someone else is living in a completely different part of the world that you've never heard about. He stays in Kazakhstan, he stays in Eritrea, and all of them are participating in the blockchain. I've never seen you before. How then can I trust you? This is one reason why consensus mechanism is important. Also, so that every single state of the blockchain would remain the same. So it's not like you're going to check the scan on this person, this thing, and you are seeing it. This person literally said he has a cent $100, but it is showing $20. And in this place, it is showing $10 here. So which one will I choose as the truth? So that is why it's important that a chain has security, and that security is the consensus mechanism. Basically, it's one of the securities to maintain integrity and single truth version of the truth. Then I made mention from yesterday's class that there are different types of consensus mechanism used by different chains. We have proof of work. Proof of work requires the nodes, which are the miners, to solve complex mathematical problems, to validate transactions and create new blocks. This is used by Bitcoin. I explained this yesterday. So the example I showed earlier showed mining, and that has to do with proof of work. So it had to mine the transaction to create a new block, and the new block will then do what? Will be linked to the previous block. And this is usually done by what we call miners. Now, some people might ask some questions, which I was expecting for someone at least to ask, that these people that are mining, that are running this blockchain, that are, participating, they are running it, their laptop is on 24/7 to run it, or they paid for cloud servers or VPS to participate in this blockchain. What is their reward? Is there anything there for them? Nobody asked me the question, so I'm not saying anything about it yet. So unless someone have asked me, then I would have spoken more about it. But then don't worry, you definitely hear about what their reward is as we continue talking about what a blockchain is. Another thing, or another type of consensus mechanism, is proof of stake, POS. It's a situation whereby all the validators, they are willing to stake an amount of coin as a collateral if they misbehave. So if they misbehave, their stake is being slashed. And I gave an example of that is Ethereum. Ethereum used to use proof of work before, but they switched from proof of work to proof of stake. One of the reasons is because proof of work actually consumes so much computation. And so much computation includes electricity, includes internet, includes, air conditioning that is used to cool the GPUs and their sink and the gadgets that are being used for this mining. So Ethereum literally moved from, proof of work to proof of stake for this reason. So there are little or minimal computation need to get involved in it. But instead, all you have to do is to have a stake. That is, instead you use KUDI stake to join the network. Another one we have is delegated proof of stake. In this situation, a participant votes for a small number of delegates to validate the transaction and to create a new block. So this is a different type of consensus mechanism that is being used by a different system entirely. So One other one I will talk about is the Byzantine fault tolerance. And the Byzantine fault tolerance is another consensus mechanism. The word Byzantine actually is not a new word. It's actually a kind of mechanism that was used years ago. And it was used by warriors, actually. It was a sign to ensure that it was a sign to assure consensus, actually. Imagine they sent someone to get information probably from an enemy or something, and at the end of the day, they want to be sure that, okay, this information is correct. They use the Byzantine method to ensure that it is correct. So what does this do? It ensures that the system can continue to function correctly, even if some nodes act maliciously, and it is used by Hyperledger Fabric. So at your own time, I want you to do more research on the Byzantine. It's actually an interesting story of how wars are being fought sometimes back in the day, and how you can literally prove that your enemy is not lying, or the people you sent sometimes back are also not lying. So moving on, the next we are going to talk about is the benefits of the blockchain technology. What is the benefit of the blockchain technology? There's a whole lot of benefits. And there's a saying that for everywhere there's light, there's always shadows. So that means while the blockchain have benefits, there's definitely challenges and limitations. What then are the challenges and limitations? We'll come back to that after we've spoken about the benefits of the blockchain technology. One of the benefits is transparency. We've spoken about transparency extensively, that even someone asks, can someone else see the transaction I sent? The answer is yes. I can see your transaction. If you have plenty of money, I can monitor you. I can see it. So that is one of the advantages of the blockchain. You can literally see everybody's transaction, and it can literally be audited by anybody, literally. Another thing the blockchain also have is security. So you are sure that all of these transactions are not tampered with. So they literally have high integrity. So using the different cryptographic techniques, one of the cryptographic technique we made mention of is cryptographic hashes. Using it to link, like a previous block hash to link to the next block hash that is being mined to create a nonce to link the next block hash. This is a complicated, sophisticated cryptographic method of keeping and protecting data. So this is one of the benefits of the blockchain, the security. Sometimes you hear about banks that, oh, a particular bank has been, breached, it has been hacked and all of that. It's rare for you to hear about that when it comes to blockchain. When you hear about hacks, when it comes to blockchain, now these hacks are usually done on smart contracts, especially when smart contracts have vulnerabilities. All of this is what we are going to talk about when we are talking about vulnerabilities in smart contracts, and we are talking about auditing in smart contracts. But for the blockchain itself to be hacked, it is a no-no, unless something happens. And that thing, I made mention of it yesterday, that's called the 51% attack, whereby we have the person attacking has access to 51% of the node that is contributing to the decentralization of the blockchain. And it's completely impossible to have 51% power of the node for the computation. It's almost close to impossible. So that is why the blockchain can literally not be hacked. Another thing is efficiency. It automates processes and reduces the need for intermediaries. We're going to talk about some, use case of blockchains. And this particular efficiency, having no need for intermediaries, is literally a use case of the blockchain. And thinking about it, me saying I want to send Miriam money, Miriam asked that question about if I can see a transaction. So I'm going to use that for the example. Me saying I want to send Miriam some money or some coins or some cryptocurrencies on the blockchain, I don't need someone to be at the middle to help me send that money to Miriam. I'll use an example of the bank again to, expand that. If I want to send Miriam money from my own bank, I have to use the bank app or whatever resource the bank provides to me. Now, there are some situations whereby Miriam will be like, Ayo, you've not sent the money. Why? That is because the intermediary between us, that is the bank, have not released the money to reach Miriam. So that means they are standing as intermediary and it's sometimes not efficient. So why should I use something that is not efficient when I have something that's transparent and efficient? So that is one reason for as a benefit of the blockchain. Another thing is lowering costs. Sometimes you get charged excessively. You receive charges, and some of these charges are outrageous, and you'll be like, how many transactions did I make this month that I'm having so much charges? They are charging you for SMS, they are charging you for your card, they are charging you for so many things, and you start wondering, where is this charging coming from? All of that doesn't happen on the blockchain because the only charge you charge that is being charged is called the gas fee, and the gas fee is literally used to send your transaction. And we are also going to understand what the gas fee is also used for, because that is not the only reason why the gas fee is put into place. Another thing is traceability. You can literally see the clear record of everything that has happened on the blockchain. So you can see the origin, that is where a particular transaction started from and where the transaction ends at. Now, let me give you a vivid example of this. Imagine someone that stole someone's private key and then he tried to move all the money from that private key, that's from the wallet. He tried to move it from the wallet. He moves it from wallet A. Let's imagine the wallet is trying to move it from his wallet A. So he moves the money from wallet A to wallet B, C, and D. So he split it up into wallets B, C, and D. Then from wallets B, C, and D, from wallet B, he splits some of the money again to another wallet. All of these transactions, as he is splitting it to all of the wallets, every single one can be traced. So this is another benefit of the blockchain. So if someone steals your money or something, you can trace it, but that does not mean you can get the person because you don't have the private key to the wallet that this person is sending it to. But then it literally means that eventually when the money gets to a centralized exchange, and a person, centralized exchange, we call it centralized. You have your private data, that is, they know who you are. You have to sign up with your name, your email, and all of that. They can literally get access to you. So at that particular point, you can get access to, knowing where and who the money was sent out eventually to. So that is literally the list of benefits of the blockchain. You can think of other benefits of the blockchain at the end of the day. Can we hear your question? Your hand is raised up.
Yes, in terms of traceability, there is a possibility to reverse the transaction if you maybe you want to reverse for in any other reason.
Correct me, I want to pronounce your name.
You can call me Chaliga. Chaliga is
okay, Chaliga. Chaliga.
Yes.
Great. So one of what we have been discussing from the of the property of the blockchain, if you go back to the beginning of the class, is something immutability. The blockchain is immutable. So once a transaction has been recorded, it cannot be altered or reversed. Did you get that? So if I send money out of a wallet, it has gone. Oh. So for example, you are trying to send your money out of your wallet, or you are trying to make a transaction, and then you make mistake of the address you are sending it to. Bye-bye. The money is gone. Because it is what? It is immutable and it is irreversible.
Is it having the power to validate it, the sender maybe and the receiver before you click send the transaction?
Now, there are different, it's all about the UI. Now, when we talk about what you are now talking about comes to user experience. Now, different wallet providers give users the opportunity to validate that, are you sure this is the address you want to send to? If you click on yes, this is the address I want to send to, and you send the transaction, that's gone. So before any transaction you send, you have to look at the address very well before you send the transaction. Notice that we have been talking about cryptocurrency, sending money. Remember, that is just one single application of the blockchain. Our class will be ending here, but I'll give you a preview of what we'll be talking about tomorrow. Use cases of blockchain. Although we were unable to talk about the challenges and limitations of the blockchain, the class tomorrow would also include this. So thank you so much, everyone. And I appreciate the time you've taken to join the class. And I will be stopping the recording now. And yeah, it's good to have you. Joanne, I think you have a question. I think you have a question.
Mr. Ayo, where can I get the workbook, or can you hear me?
Yeah, I can hear you.
Hello?
Yeah, I can hear you. I can hear you.
Yes, where can one get the module?
Okay. So
where can one get the Stellar module that we've been reading from, so that we can also read
ahead of the classes? Yeah,
Did you get me?
I got you. So I prepare all of the slides that is being done for the class. So for every single class, at the end of the class, the slides are being compiled. In fact, this class has a recording that is being compiled, and each class videos and the lectures are being sent together. You're welcome. I appreciate seeing all of those messages. All of these are compiled together inside the Notion page, and you can literally have access to the information, basically. But if there's something you want to do about reading about Stellar even before the class, that's all right. Remember, we are just starting from introduction to blockchain, and we've not spoken so much about Stellar. But don't worry, by the end of the semester, everything you'll be hearing would be about Stellar. But it is always great to introduce the fundamentals of the blockchain before, saying anything about Stellar. So you have to understand the ground level of everything. But if you want to go straight to Stellar before then I will recommend you going to the official Stellar documentation, and you can literally get more information about that. Having yourself updated before the class begins, then that would also be great.
No. I was just looking for the previous slides because I just joined today, so
okay,
I want to catch up.
You will get access to it. Both the video for yesterday's class and the slide for yesterday's class, the video for today's class. The video for yesterday's class, I have uploaded it. It is now on the official Stellar Ambassadors channel. It is there. And the link will be posted by Nomad on the Notion page. I've informed her that, okay, I've uploaded it. And also the slides also has been sent out to her, and you would just get it from the Notion page. The Notion page compiles all of these videos and slides together. So you would have access to it. So at this particular point, I thank every single person that was able to enjoy this class. I'll be stopping the recording now, and then we look forward to meeting tomorrow.